Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count of interesting subarrays. So the problem states that we are given an array nums, an integer called modulo, and an integer called k. And our job is to find the count of subarrays that are considered interesting. And it is considered interesting if we have count be the number of indices I in the range left to right, such that nums of I mod by modulo is equal to k. Then, if count mod by modulo is also equal to k, then it is considered an interesting subarray, and we will return the number of interesting subarrays. So if we look at this example, the only element that when we mod by modulo, which is 2, is equal to 1 is 3. Because 2 modulo 2 will equal to 0, and 4 modulo 2 is also equal to 0. So then we will return 3 because this subarray modded by 2 is equal to 1, this subarray modded by 2 is equal to 1, and this subarray modded by 2 is equal to 1. So we return 3. So now that we have seen some examples, let's get to how we can solve this problem. So for this equation, the sum of r will represent the count up to the right side, and left minus 1 would be up to left minus 1. And this is the equation that we want to satisfy. The count on the right side minus the count on left minus 1. And if we want to modulo it, we want it to be equal to k, as it says it right here. So if we were to derive this equation, we realize that we can first expand the modulo, and then we can switch this spot by adding it to this side and then subtracting k to this side. And then we can modulo both sides, but then we realize that moduloing twice is redundant, so we reduce 1 on that side, and then we realize that we don't need to modulo here, so we can reduce that, and then this is the equation that we derive at, and this will be what we use to solve this problem. So what we can do is first we can set up the count hash map with the key 0 is equal to 1 for the initial case, and we're going to iterate through this array, and as we iterate, if that number mod by the modulo is equal to k, then we will increment the total by 1, and then we will use the formula. So we will take the count of the key of total minus k mod by modulo, and we will add the value to the result, and then we need to update the count by the key total mod modulo plus 1, and then we'll continue that until we come to the end of the array. So let's go over this example real quick. So first we start here, 3 modulo 3 is equal to 0, and 1 minus 0 modulo 3 is equal to 1. We don't have that in the hash map, so we add nothing to result, but then we need to update count of key 1 by 1. So now we go to the next array, 9 modulo 3 is equal to 0, which is k, so we update total again, and total minus k, which is 2 modulo 3 is equal to 2, is not in count, so we don't update result or anything, but we do need to update count, so we will add 2 to the hash map, and now we come to 1. 1 modulo 3 does not equal to k, so we don't need to update total, but 2 minus 0 modulo 3 is equal to 2, and we see that we have 2 in here, so we add this to result, and as you can see, this on its own is a valid subarray. And now we move on to the next element. 6 modulo 3 is equal to 0, so we update the total to 3 again, and 3 minus 0 modulo 3 is equal to 0, so we add 1 to result, and as you can see, we can make a subarray with this. Now we come to 1. 1 modulo 3 is equal to 1. Total minus k modulo 3 is equal to 0. So we add 2 to result. And as you can see, we can make this subarray and we can make this subarray. So now the result is 4, and we need to update the count. And yeah, this is the same thing. We see that there's 3, so we will add 3 to result. And as you can see, we can add this subarray, and we can add this subarray. Finally, we come to the last element. 3 modulo 3 is equal to 0, so we update total to 4. 4 minus k, which is 4 modulo 3, is equal to 1, so we will add 1 to result. And as you can see, we can make this subarray. And then we also need to update the count here. And now that we have come to the end, we can return 8 as our result. So the time complexity would be O of n, where n is the number of elements in the array, because that is what we are iterating through. And the space complexity would be O of the minimum of n and m, because this space of this hash map will depend on the minimum of the number of the elements or the modulo number. So now let's get to the coding part. So first we initialize the counter with the element 0, 1 inside. Initialize result to 0 and total to 0, and then now we loop through the length of nums, so for I in range length of nums. So first we check if the number mod modulo is equal to k. If it is, we increase the total, and then now we update the result, so it would be the hash map of total minus k mod modulo. Then we will add whatever the value of that key it is to result. And then we need to update count. So we'll take the total mod modulo and then add that key to the value, increment by 1, and then we return result, see if it works. Okay, perfect. Thank you all for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.